Part 2, this is for questions 7 to 11. Question 7 is coming from differential equations. A curve is such that the gradient at a general point with coordinates x, y is proportional to y out of the square root of x plus 1. The curve passes through the points with coordinates 0, 1, then 3e. That means we are going to get two constants here. That's why they have given us these two to solve. Okay? By setting up and solving a differential equation, find the equation of the curve expressing y in terms of x. Now, dy dx, we know that it is the gradient, okay? The gradient of the curve is denoted by dy dx. So they say that it is proportional. So we shall put the proportionality sign here. Then we write y out of the square root of x plus what? 1. Then to eliminate this proportionality sign, we put a proportionality what? Constant. So this one is going to be equal to k, then y out of root of x plus 1. Now, the first constant, I said that we are going to have two constants. The first constant is this proportionality constant. And then the next one will be when we integrate. You see that? All right. Now, the first thing we are supposed to do, this is our differential equation. So we are supposed to separate the variables and then we integrate. So separating variables and integrating, this one gives us what? So to separate the variables, I'll just cross multiply here. That means this one will come down here, then the dx up there. So that means I can have 1 over y, then dy, which will be equal to k, then out of the square root of x plus 1, okay, then dx. You see that? Then, of course, another person can also take this k down here, but there is no need. Just leave it here. It is better. Then we are going to integrate. When I differentiate this y, I get exactly what is up here. That means here we are having the natural log of y, not so. Natural log of y. Then this way, I'm not going to put the constant here because even this other side, I will put a constant. And these constants are different because we are not integrating the same functions. So a constant, then minus a constant. This way you get a certain constant, not so? So you just choose to put the constant on one side, that constant of integration. So here, this one is actually the same as saying this is x plus, I can put the k out, then x plus 1 to the power of negative 1. You see that? So you have natural log of y, which will be equal to, now we increase the power by 1, which will be a half. Then we divide by that new power. But then times the derivative of what is coming from inside here. Because suppose we had, let's say, 2x plus 1, then that means here we would multiply by 2. You see that? All right. Then from there, I can put a c. So meaning that natural log of y shall be equal to, of course, this one will somersault and then goes up there. You will get 2k and then x plus 1 to the power of a half plus c. So this equation I've gotten here is what we call the general solution of the differential equation. Now, after getting this constant here, then I'm going to get the particular solution of the equation. Now, we are supposed to substitute these values here, okay? Now, let us start. Suppose we use 0, 1. So when we use 0, 1, we shall have here natural log of 1. The value of y is 1. And then the value of x is a 0. That means here we shall have this, then plus c. So what does this imply? That, of course, this one is a 0. Then when this one comes this side, it will be a negative. So therefore, c shall be equal to negative 2k. You see that? I keep this one here. I will need it somewhere. Then we are also going to use this other point here, 3e. So we shall put here 3 and then e. So Our y is e, so natural log of e, of course, that one will give us a 1. Then we shall get 2k here, and then we shall have 3 plus 1, that is a 4, then power half, then plus our c here. Okay, so this one is a 1, then minus, this is 2 times 2, that is a 4. So minus 4k, this one will give us c. Now, do you see these two equations? We can then equate them. So therefore, 1 minus 4k will be equal to negative 2k, not so? Take this one this side, we shall have 1 which is equal to positive 4k, then minus the 2k, and then this one will give us 2k which is equal to 1. So therefore k is equal to a half. Are we there? If k is equal to a half, then this simply implies that c shall be equal to negative 2 times that a half. Then c becomes a negative 1. Are we there? Then after that, we can go back to our particular solution. And our particular solution, we had it here. So we have natural log of y. This one is equal to 2k. Now 2k is a 1. Are we there? You connect here. So that is a 1. Then times this x plus 1 to the power of a half. And then our c is a minus 1. Now, we can make y the subject of the formula. So our y is going to be equal to e to the power of whatever we are having here. So e power this x plus 1, I can write it like this. It is to the power of a half. So I can put it in the square root like that, then minus 1. So the whole of this will be the power of the e. Now, don't write something like this, because this one has to be up here, okay? Like that. So I can say minus 1, then I put the whole of this in brackets like that, okay? Then I can extend that one there. So that will be the equation of that curve there. Question 8, the equation of a curve is this one here for x ranging from negative pi over 2 to pi over 2. Find the x coordinates of the stationary points of the curve. Give your answers correct to 3 decimal places where appropriate. Now here they are saying answers. That means it is more than 1. Now this is a product of 2 functions, so we are going to use the product rule, not so? So for us to get dy dx here, we are going to keep this exponential function constant, then we differentiate the tan squared. I can actually write it as tan x, then I put the square up there, then plus. Now I keep tan squared x constant, and then I differentiate e to the power of negative 5 of x. You see that? And then after, we shall equate this one to 0, because you know that for stationary points, dy dx is equal to 0. So this is something very, very important to note. For stationary points, there is even a mark given for that. You differentiate and then you equate to 0. Equating to 0 is a mark, okay? So for stationary points, dy dx will be equal to 0. Now, let's begin. So we are keeping this one here, and then differentiate this, so you will drop the power using chain rule. So times 2, then tan of x, and then I reduce the power by 1, so this one will be to the power of 1. Then differentiate here. When you differentiate tan x, you get sec squared, not so? So sec squared x. Then you also come to this one, it is tan squared x. Then when you differentiate the exponential function, let me note it here. When you differentiate an exponential function, you get the power, you differentiate it, then you multiply that exponential function, okay? So this is what we are getting. Now here the power is negative 5 of x, so when you differentiate with respect to x, you'll get a negative 5. Then e to the power of this negative 5 of x. Then we equate to 0. Is that clear? Then the next thing to do is to pull out what is common. I can see e to the power of negative 5 of x is common. Then here we are having this. And this is 2 tan of x. I can express this in terms of tan. And this one can be 1 plus tan squared x. Are we there? And then here we shall have minus 5 tan squared x. Then this one will be equal to 0. Now e to the power of this one here, okay, or I can have maybe this one written down. Now let us multiply in here. What do we get? In fact, even tan x is common. Let us pull it outside. So we get e to the power of negative 5x, then pull out the tan x is common. And then here we shall remain with this, which is 1 plus tan squared. I think it is going to be a 2. So there is this 2, then times this. So we have 2, then plus 2 tan squared x, and then minus 5 tan squared of x, isn't it? This one is equal to 0. No, actually there is something wrong here. Since I pulled out a tan x, that means here we are remaining with 5 tan x. You see that? Which is equal to 0. Now this is e to the power of negative 5 of x, then tan of x. Then inside here I can rearrange this. Then we get 2 tan squared x minus 5 tan of x, then plus 2. This one is equal to 0. Now this is a quadratic in tan x. Now we are having 3 factors here. There is this, and this one here. So we equate all of them to 0. So e to the power of negative 5x is equal to 0. There is no number we can power e with to end up with a 0. So therefore this one is undefined. So we do with that. Then we also have tan of x, which is equal to 0. Of course, your x is going to be the arctan of 0. And then what are we going to get? We are going to get a 0. So x will be equal to 0. Then we have 180, which is pi. Then we have 2 pi, like that. Then we also now equate this one to 0. But of course, based on the what we are having here as the domain, then we shall take 0 only. Okay. Now let us solve this one here. 2 tan squared x minus 5 tan of x minus 2. This one is equal to 0. Can this one be factorized? I think so. 2 times negative 2. That one can be negative 4. So two numbers when multiplied, they give us negative 4. But when added, they give us negative 5. I think that one can be... No. Actually, this is a positive here. That means we have a positive here. So it can be negative 1 and negative 4. You add these ones, they give you negative 5. You multiply them, they give you this 4. But of course, we can do this one very fast on a calculator, and then we go. Mod, then equation is 5, and then quadratic is 3. Then we have a 2, we have a negative 5, and then a positive 2. So we get 2, and then a half. I will skip space, and then I say tan of x is equal to a half, and also tan of x is equal to 2. Now, you need to show the examiner the attempt to solve this quadratic equation. So give us the factor from which these two roots come, okay? Now we can cross multiply. The reason as to why I leave this space is to use it for factorizing. So when we cross multiply, we shall get 2 tan of x now is equal to 1. Now bring this one here. So it will be minus 1. So this is the factor that gives us this, okay? Then what else? You also bring this one here. So that one will be tan of x, then minus 2, which is equal to 0. Here you have already cheated the examiner. This is an attempt to solve this quadratic equation. You see that? Okay. Now next, get this one here. And then we say that our x is going to be equal to the arctan of a half. And then also our x is going to be the arctan of 2. Since these ones are positives, then we are going to pick angles in the first quadrant and also the third quadrant. That is where tan is positive. But since this one doesn't exceed the first quadrant, okay, then we are going, in fact, here we are using the 2 quadrants. So moving anticlockwise is negative. I mean, yes, the angles are positive. So this is 90, which is pi over 2. Then moving clockwise, the angles are negative. So we shall have negative pi over 2. That means we are looking at these 2 quadrants here. But in the first quadrant, all are positive. Then in the fourth quadrant, it is only cosine, which is positive. So suppose this one here was, maybe one of them was negative. That means we would take the negative answer here in the fourth quadrant, but all are positive. So we are going to take the answer in the first quadrant. Is that clear? All right. Now, what is the arctan of a half? You make sure that your calculator is in radians because we are given the domain in radians. This one is in degrees, so I will have to change it. Shift, then mod. Radians is option 4. And then arctan of 0.5. This one gives us 0.464. 0.464. Because here you write these answers in radians to 3 significant figures. Okay? Then this other one here, arctan of 2, I'll come back here and then I put a 2. That is 1.107. 1.11. Did they give us the degree of accuracy? They said 3 decimal places. We are not giving to 3 significant figures, but 3 decimal places. So this will be 1.07. Okay? And there is also 0. So we are having 3 answers here. 0, which we are getting from here. Then the answer to this and also the answer to this. So these are our final answers. Question 9, I can see partial fractions. If they give you partial fractions in part A, then expect the second part to come from integration or binomial expansions. And then before you proceed, you have to always look at the degree of the numerator. The degree of the numerator, that is the highest power of x. So this is a 2. And then the degree of the denominator. So here we can see that the x will multiply with this one. When I'm multiplying out the brackets, I'll get x cubed. That means the highest power here is a 3. So the degree of the denominator is a 3. So if you find that the degree of the numerator is less than the degree of the denominator, you can go ahead and you express in partial fractions. But if you find that the degree of the numerator is greater or equal to the degree of the denominator, that is an improper fraction. So you first long divide. Okay? But for this case, this one is okay. We can just proceed. So 14 minus 3x then plus the 2x squared out of 2 plus x and then times 3 plus x squared. This one here, we can see that this is a linear factor. So we shall have a, then out of that 2 plus x. And then this is a non-factorizable quadratic factor. They can also give you a quadratic factor here, which is factorizable. Like for example, if they give you 4 minus 2x, no, I mean 4 minus x squared. This is a difference of 2 squares. This is 2 squared minus x squared. That means you can write this as 2 plus x and then 2 minus x. So you see that this one is factorizable. So it gives you the linear factors. So you need to be very careful. Okay? All right, now we can proceed. we are going to put, this is non-factorizable quadratic factor. We shall have here bx, then plus c out of 3 plus x squared. Then we need to get one fraction from here. So to get one fraction from here, we can get the common denominator by multiplying these two. Okay, so when we multiply these two, actually we get exactly what is here, not so? Now this is the common denominator, so divide by this one. That means this 2 plus x is going to cancel with this one, and then you remain with this, which you will multiply with the a, not so? So meaning we shall have a, then times 3 plus x squared, then plus, again you get this one here, divide by this. That means this one will cancel with this. You remain with the 2 plus x, then you will multiply it with the bx plus c. So we shall have bx here plus c multiplying with the 2 plus x. And then here we shall equate to this numerator here. And I've always shown why we equate to the numerator. Why do we equate to the numerator? This one here is over this denominator here. Are we there? But again, even this one here is out of this denominator here. Now you can see that the denominator here is the same as for this, so it can easily cancel. And then here the numerator has to be equal to this other one here. So that means after multiplying out everything that you get here, okay, then you should put this one and then equate it to the numerator. Now our task is to find the value of a, value of b, and value of what? C. And how are we going to do that? You can get values of x that you want, you can substitute in here, but better to get the values of x that can terminate some of the terms here, and then you solve for others. Like for example, if I get this one and I equate it to 0, x is going to be equal to negative 2. So I would say if x is equal to negative 2, so you substitute here, you are going to get 4, then plus 3, 7. So you get 7a. Now this one is a negative 2 plus 2. That one disappears. So this whole thing goes. And then we shall equate. We come to this one here. What do we get? 14 minus 3 times negative 2, then plus 2 times negative 2, then squared. We are getting 28. So you get 28 here. This therefore implies that a is going to be equal to 4 when you divide all through by 7. Are we there? Then I can see bx here. If I let my x to be equal to 0, okay, that means b will go, and then here I will be having 3a, then plus, since b has gone, then this one is a 0, then we shall have 2 times the c, so that will be 2c, and then of course these terms will go, and then that one will be equal to 14. So what will be our c? Our c will be equal to 14 minus 3a. So 3 times the a, which is a 4. Now this is 14 minus 12. You are getting a 2. Then divide by 2. That means c will be equal to what? 1. Is that clear? Then next, we are supposed to find the value of b. Since the values of x that I can substitute in here to terminate some of the terms are done, because when you equate this one to 0, you are not going to get the real value. So you use any other value of x you want. For example, if I say x is equal to 1, that means here I'll have 1 plus 3, that will be a 4, then times a, that is 4a. Then we come to this one here, 1 plus 2, that will be 3, then times everything here. So we have 3b, then plus 3c. Then this one will be equal to 14 minus 3, that is 11. Then 11 plus 2, that will be a 13. So this one is equal to 13. Making b the subject of the formula, our b is going to be equal to 13 minus 4a. So 4 times our a is a 4, then minus 3c, and c is a 1 here. Then we divide by 3 here. Now this is 13 minus 16. Isn't that a negative 3? So we get minus 3. Then minus this 3 here. that will be minus 6. Then minus 6 divided by 3, that will be minus 2. So that means b will be equal to a negative 2. Then this simply implies that our f of x here is going to be equal to a is a 4, then we shall divide it by the 2 plus x, and then plus our b is a negative 2, so we shall have negative 2 of x, then our c is a 1, then we divide by 3 plus x squared. Okay, and that is our final answer here. Then part B, hence obtain the expansion of f of x in ascending powers of x up to and including the term in x squared. So here it is coming from binomial expansions. So our f of x is equal to 4 using rules of indices. I'll take this one up here, so it will be 2 plus x, then to the power of negative 1, and then plus, this will be 1 minus the 2x. I had negative 2x, then plus 1, but it is better to write it, or whichever you want. So I'm going to write this one here, 1 minus 2x, then times 3, then plus x squared, then to the power of negative 1. And then I'm going to expand this, then afterwards I multiply by 4, and also this one, after expanding it, I multiply by this one here. Is that clear? Okay. Now using the binomial expansion, which is a plus b to the power of n, we shall get the a, we power it with the n, then b, power it with the 0, then over 0 factorial. The power of the b is the one that we put in the factorial, then plus. Now, the next terms will be, you'll be like differentiating with respect to a, so you drop the power. When you drop the power, it will be there, then you reduce this by 1. Now, when a loses the power, then b picks that power. Then the power of the b is the one that comes into the factorial. So again, drop this one here, you'll get n, then times n minus 1, then now a, now reduce the n minus 1 by 1, so it will be n minus 2, and then this b will be to the power of negative, this b will be to the power of 2, then we divide by 2 factorial, and then we continue like that. Now, starting with this one here, some people like to make this one a 1, so they say this one will be 2, then 1, then plus x, then that. So, but me, I don't do that. I just do it. I just do it all at once. So 2, then power negative 1, x here power 0 out of 0 factorial, then plus. Now drop this power. So you have negative 1, then times 2 power negative 2, and then x power 1, then out of 1 factorial. I'll go up to the term in x squared, then drop this one down. So we shall have negative 1, then times negative 2, and then our 2 here now will be to the power of negative 3. Then x here will be to the power of 2, then out of the 2 factorial, plus the terms that come forth, which we ignore. Now, when you add these powers here, all of them are going to give you this one here, the negative 1. Now, we simplify this. Of course, this one is going to be 1 out of 2. 0 factorial is 1 because there is one way of arranging an empty set. And then this one here will go down. We shall have negative a quarter, okay, of x. And then this one here will cancel with this. And then this one will be 1 over 8. So positive 1 out of 8 of x squared, plus the terms that come forth. Then how about this one here? We have 3, then plus x squared, then power negative 1. So we shall have here 3 to the power of negative 1, then x squared to the power of 0 out of 0 factorial, then plus, drop this one here, you get negative 1, then 3 to the power of now negative 2, then x to the power of 2, then power 1, then out of 0, out of 1 factorial. Now, what I'm going to do here, I'm going to stop here, plus any other term that comes forth, because the next term will be, this x here will be to the power of 2. Now this one will be to the power of 4, yet we are supposed to stop on x to the power of what? 2. You see that? So I'm stopping there. Now let me simplify this. This is 1 over 3. Then here, this is negative 1 over 9. Because this one here is 1 over 3 squared, not so? Then of x squared, and the rest that comes forth. So implying that our f of x is going to be, remember there is a 4 here, so 4 then times what we got here, which is a half, then minus 1 over 4 of x, then plus 1 over 8 of x squared. Then we have this one, which is 1 minus 2x, then times a third. The expansion of this, we have seen it is this one here. So a third, then minus 1 out of 9 of x squared, and then whatever comes forth. Now, I'm going to have the constant term here will be 4 times a half. That would be a 2. Are we there? Then there is this one here, also times this a third. Or maybe let me multiply out everything. So this one will give us a 2. Then this will give us a minus x. Then this 4 will go in here 2 times. So we shall have a half of x squared. Then plus, you have 1 times everything here. That will be a third, then minus 1 over 9 of x squared. Now this one times this, we shall get minus 2 over 3 of x. I will not multiply this with this because it will end in x power 3. So we ignore those higher powers, okay? Like that. Then we shall have 2, okay? Maybe I can say 2 plus a third. Then the terms in x, here there is a minus 1 as the coefficient of x. And then here there is, not there, it is here, minus 2 out of 3 of x. And then x squared, we are seeing this a half. Then also this minus 1 over 9, okay? The rest we ignore. Okay, now we proceed. This is 2 times 3, that is 6, then plus 1, 7. So we shall get 7 over 3. Our f of x here is going to be 7 over 3. And then here, 3 times this, you're getting negative 3, then minus 2 over 3. That will be negative 5 over 3. So we have minus 5 out of 3 of x. And then here, we get 9 minus 2, that is 7 out of 18. And then of x squared, ignoring the rest of the terms. So that is that. Question 10 is coming from circular measure, which is actually set in paper 1. But there is something here that we also want to pick from here. Now, x here is expressed in terms of x here. That means we cannot solve such equations using the usual algebraic methods. So we solve them using the numerical methods. So this one is coming from a topic of numerical methods, though we are applying what? Circular measure. The diagram shows a trapezium ABCD in which AD is equal to BC, which is equal to R, and AB is equal to twice R, because this one is R, this one is R, not so? Then they are saying here that the acute angles BAD and ABC are both equal to x in radians. Circular arcs of radius R with centers A and B meet at M, the midpoint of the line AB. But given that the sum of the areas of the shaded sectors is 90% of the area of the trapezium, show that x satisfies this equation here. All right. Now, what do we have here? Suppose Of course, now here they are talking about the area of the trapezium. So if I'm to get the area of the trapezium, I need height. So I'm going to create one here, the height. Okay. If that is the one there, I'm also going to, in fact, let me make it dotted so that it doesn't interfere with what was given. This same height here is what we are also having here. Not so? And of course, this one is going to be perpendicular, just like this one here. Okay. This line here is perpendicular to this one here. So suppose I label this as H. Okay. Then now moving from here to here, let me say that is Y. Okay. Then also from here to here, this one is also what? Y. Remember R, for which it is from here up to here. Now that means this distance here that is remaining is going to be the whole of this, which is 2R, then minus the 2Y. Don't so? So we have here 2R minus 2Y. Is that clear? That is what we are having here. Then, of course, since this one is a right angled triangle, then we can use SOHCAHTOA, not so? So cosine of x here is going to be equal to the adjacent out of the hypotenuse. So adjacent is y out of the hypotenuse, which is what? R. So meaning y will be equal to r cosine of x. Is that clear? Then if we have 2r minus 2y, okay, 2r minus 2y, this one will therefore be equal to 2r minus our 2y. So this will be 2, then y is r cosine of x. So if I can factorize out the 2r, then this one will be 1 minus cosine of x. Okay, I keep that. Then we also have sine of x. Sine of x is equal to opposite out of hypotenuse. So that will be h out of r. So meaning that h will be equal to r sine of x. Are we there? Now, how do we get area of trapezium? Area of trapezium, this one here is going to be equal to a half, then h into a plus b, not so? So this is a half, and then our height is this one here, which is r sine of x, and then a, that is this one here, b is this one here, the two parallel sides. So this DC here is this one here, okay, because this one is a rectangle, you can see. So this length here is equal to this one down here. So I'm going to have 2r minus 2y, which is this one here. So that is 2r into 1 minus cos of x. Are we there? Then plus our b is the whole of this, which is 2r, like that. Then I think we can simplify this. I can pull out something that is common. From here, 2r is common, not so? So I can pull it out, and then we have 1 minus cosine of x, then plus a 1 here. So that means, of course, this one will cancel with that. Then r times r, that one will be r squared, then sine of x. And then in here, we are having 2 minus the cosine of x. Does that make sense? Okay. Then they said that 90% of the area of trapezium, is equal to sum of areas of the shaded sectors, sum of areas, let me just say sum of shaded sector areas. Okay, now this is 90%. 90% is the same as 0.9. 0.9. Area of the trapezium is this one here. So 0.9 r squared, then sine of x, and then 2 minus the cosine of x. Then this one will be equal to, you know that area of a sector is a half r squared theta. So it is a half r squared. The theta we are talking about is this x here. So I'll put an x here. Then there are two of them, so times 2. Answer? And they are identical. If you can check very well here, this one is identical to this, or they are similar. Then from there, of course, this one will go, and then we have r squared x will be equal to 0.9 r squared sine of x into 2 minus cosine of x. Now look at what we are having here. Don't you think this r squared is going to cancel with this? Yes. And then our x is now going to be equal to 0.9, then sine of x, and then 2 minus the cosine of x. And that is that. So they separated these two, but it is the same thing, okay? It's the same thing as this. I can write this sine of x here, or I can leave it there. Then next, part B, verify by calculation that x lies between 0.5 and 0.7. If this is the graph that we have drawn probably, and then we see that this graph here cuts x-axis at this point here, this is what we call the root of the function. A root of the function is that value of x that you're going to put in the function, and it reduces it to 0. Are we there? Then we can see a value of x that is on the left of the root. Then also there's a value of x on the right of the root. This value of x on the left of the root can correspond to a y value that is above the x-axis. And this one here is going to be a positive value. And then this one here will give a y value that corresponds to, will give a y value here, but it is going to be a negative based on what I've drawn here. Now that means if you get a root which is in between two values, those two values, when substituted into the function, they should give us different signs. One should give us a positive, and then the other should give us a what? A minus. Now, right from here, what we can do is to bring everything onto one side. So we can have x, then minus 0.9 sine of x, then times, well, the reason as to why they put this one, this other side, is to have something like this, such that people do not confuse this x with what is inside here, okay? Now, I'm also going to write it that way. 0.9, then we have 2 minus the cosine of x, then sine of x. In fact, let me also get this one done like that perfectly. So I'm going to put this one here, then this one, bring it back here, and then we write it systematically like that. So since I've brought this one this side, then this one will be equal to 0. You can bring this one this side, or you take this one this other side, okay? It doesn't matter which one you take. So that means the function of x here is going to be x here minus the 0.9, then 2 minus the cosine of x, then times the sine of x, okay? Remember, for a root, f of x is supposed to be equal to what? 0. So this value of x in here, which reduces the function to the 0, is what we call the root. So that's why we need to find the equation of the function, okay? which is equal to what? To the 0. Okay. Now we put in these two values and then we see, so f of 0.5, we shall get 0.5 here minus 0.9 into 2 minus the cosine of 0.5, then sine of 0.5. What do we get here? Then we also get f of 0.7. So we have 0.7 minus 0.9, then 2 minus the cosine of 0.7, and then sine of 0.7. Since we are having trigonometric functions in here, the calculator must be in radians. Okay, the calculator must be in radians. Very important. Then let's put in the calculator and we see one of these should give us a negative and then the other a positive. My calculator is already in radians, so I just proceed 0.5 minus 0.9, then times, this is 2 minus cosine of 0.5, then sine of 0.5. That is 0.0156. And the rest of those figures, 0.0156. There was a 9, a 5, and then the rest of those other figures, okay, that come forth. Then how about this one here? Where there is a 0.5, I'm going to put a 0.7. Even here, 0.7, and then sine of also 0.7. So this one is a negative. That is negative 0.0161, negative 0.016, then 1, 3, there's a 9, and then the rest of those other figures. Now, since we are seeing a change in the sign, we can then conclude. Don't just stop there. You say, since there is a sign change, since there is a sign change between f of 0.5 and f of 0.7, then the root, then in fact I just write this one here, x lies between 0.5 and 0.7. But C, show that if a sequence of values in this interval given by the iterative formula, this one converges, then it converges to the root of the equation in part A. The only thing that you're supposed to do here is to rearrange this equation to see that you get what we are given in part A. So what you have to do is to drop the ends here. You have x, which is equal to the arc cos of 2, then minus the x out of 0.9 sine of x. Are we there? Then bring this one back here. So we shall get cosine of x, which is equal to 2 minus x out of 0.9, then sine of x. Okay, then I can bring this one this side, then I take this one here. So we shall have x out of 0.9 sine of x, which is equal to 2 minus the cosine of x. Then when you cross multiply, your x is going to be 0.9 sine of x times the 2 minus the cosine of x. Isn't this what we had at first when we were given 0.9, then times 2 minus the cosine of x, and then the sine was put this other side? So this is exactly what is there. So you just rearrange. Okay, rearranging gives us what? That. The next part D, we are now supposed to find the value of x. Use this iterative formula to determine x correct to 2 decimal places, give the result of each iteration to 4 decimal places. Now we are supposed to get what we call an initial approximation. We are not given the initial approximation, but we can use 0.5, 0.6, we can use 0.7, we can use 0.5 something, any value in there, okay? But of course, when you iterate, we are all going to get the same value, but I always recommend that your initial approximation be the average of those two. Okay, let the initial approximation be, let's say, x1, which is going to be the average of the two. So 0.5 plus 0.7, because remember, we proved that it is in between these two, not so? Okay, then this one will give us 0.6. Then our x2 shall be equal to, we are substituting in this one given here. This is the iterative formula here. So the arc cos of, that is the arc cosine of 2, then minus 0.6 out of now 0.9 sine of x, which x is now 0.6. So what do you get here? Remember, your calculator has to be in radians. Arc cos of 2 minus 0.6, then we divide by 0.9 sine of 0.6. So you have 0.6106, 0.6106. Then the next one, you don't need to again show the substitution. You write this one here. Sometimes the space they leave might not be enough for you to substitute every now and then. So the rest you just divide there. I mean, you just substitute those values you get. You just keep on iterating, okay? So long as you show the substitution in the first one, okay? So let's put this one here. I mean, where there is 0.6. You don't go to your calculator and then you put answer. You put this rounded figure, because sometimes that one fails, many times actually. So I'll come back to this and then I put 0.6, 106. Then also down here, I'll do the same, 0.6, 106. So we get 6151, 0.6151 to 4 decimal what? Places. Then we continue, put this one in here, 6151. Then also up here, 6151. So we are getting 6170, 0.6170. When do you know that you're supposed to stop? You have to get 3 consecutive values that are giving you the same value correct to 2 decimal places. So this one here is giving us 0.62. Then this one here also 0.62. But this one here was giving us 0.61. Now, since these two are giving me the same value, that means these are the minimum number of iterations I'm supposed to perform, okay, when I'm looking for the root. Are we there? So we do one more to confirm, because you can do one more and still you get a value maybe 0.61. So that means now you have to continue. You see that? So let us do one more and we'll see whether it also gives us 0.62 correct to 2 decimal places. So I will come back to this one and then I'll put 6170. Then also down here, 6170. So we are getting 6178, 0.6178. So these three are giving us the same value, 0.62. That means the root is going to be 0.62. That is to 2 decimal places. And that is that. Question 11 is coming from vectors. With respect to the origin O, the points A and B have position vectors given by OA, which is this, and then OB is this one here. But show that OA is equal to OB and use a scalar product to calculate the angle OAB. Now OA, this one here, is also the same as saying the modulus of what? Of A. Are we there? So this is the modulus of vector OA. And that one is going to be the square root of, now here we are having 2 squared, then plus -1 squared. Of course, we have 0 squared, there is no k. So that means here we are getting 4 plus 1, that's a 5, square root of 5. And then OB shall be equal to the magnitude of vector OB. So this one will be 1 here. So there is no I, we shall have 0 squared. Then this one will be 1 squared, then plus -2, then squared. This one will also be 1, then plus the 4, 5. So it is root of 5. Therefore, OA is equal to OB. Then using the scalar product, I can draw something small here. When we are finding the angle in between the two vectors, you either open up or you close in. So this is O, this is A, this is B. I'm just using this as an example. So to open up, you say OA, you are getting the vector OA, then OB, you move away from this angle. Or to close in, you say AO, then BO, okay? Now we are going to use this OA and then OB. So we shall get vector OA, we dot it with vector OB, and then this one will be equal to this OA here, the magnitude of OA times the magnitude of vector OB, which we have gotten here, then the cosine of the angle in between. So here we are having 0, no, there is a 2, then -1, and then there is no k, so that will be 0. Then dot it with vector OB, there is no I, so we shall have 0, then 1, and then -2. Then this one will be equal to, this one, we have gotten it up here as root of 5, then times root of 5, then the cosine of theta. So 2 times 0, that will be 0, -1 times 1, that is a -1, 0 times -2, that's a that's a 0. Then this one will be equal to 5 cosine of theta. So that means cosine of theta shall be equal to -1 out of 5. And then theta shall be equal to the arc cos of this. Since this one is a minus, then it is going to give us an acute angle, which is in the second quadrant, okay? They said we give the angle in degrees, so your calculator has to be in degrees. Arc cos of -1 out of 5. This one is a negative here. So we are getting 101.5. So angle AOB shall be equal to 101.5 degrees, and this is to 1 decimal place, and that is that. The midpoint of AB is M. The point M on the line through O and M is such that PA to OA is root of 7 to 1. Part B, find the possible position vectors of P. In a small sketch, just like before, I had something like this, and also maybe like that, where I had this one as A, then this one as B. Then if I connect A to B, they have said that M is the midpoint. So maybe M is here. Okay. Then they have said that the point P, okay, this is O here. So you have OA, then the OB. The point P is on the line through O and M. This one like this. So P is on this line here. And then they are saying that PA to OA is root of 7 to 1. In other words, PA out of OA is equal to root of 7 over 1. So PA is root of 7 times OA. So that means this one, the PA, is root of 7 times this, okay? So that means PA is bigger than OA. So I can put, if I put, let's say P is around here. So PA and then OA. So by just looking at, let's say this one here, this one is bigger than this. Maybe. So it can be there. It can be where? PA. P can also be that side, because this line here is just through O and M. So P can be anywhere. It can even be this side, so that this PA is greater than OA. You see, something like that, in those different positions. So that is that. Now, what do we have to find here? What we are going to do is to find the equation of the line through O and M. Are we there? But we need to know this M here, which is a half of this, OM here. OM can be OA then plus AM. So let us first get AB. AB is OB. You get the last minus the first. Okay. So our OB was given as 0, 1, -2. And then our OA is 2, -1, 0. So this one gives us -2, and then +2, then -2. Okay. Now, this AM here is a half of this, not so? So I'm going to say OM is going to be equal to OA here, then plus AM. And OA, like we have seen here, okay, let me first write this. It is OA, then plus this is a half of AB. Master the direction A to M, then AB, okay? OA is this one here. So we have 2 -1, 0, then plus a half of AB, which is -2, 2, then -2. So what do we have here? This is 2 minus 1, that will be a 1. Then this is -1, and then this will be a +1. So that one gives us a 0. Then 0 plus -1, that's a -1. Okay? So like I said, we need to find equation of line through O and M. Remember, this one is supposed to be R is equal to point O. I can say OO, then plus lambda. The direction of vector is of course going to be OM. So we shall have R is equal to 0, 0, 0, which you don't need to write, okay? So then plus lambda, and then the OM, which is here, 1, 0, -1. Are we there? Now, if P lies on this line here, that means its coordinates must satisfy the equation of that line. Let me write that statement here. So this means that our OP then shall be equal to this one here. I'm just going to say lambda, then 0, then minus what? Lambda. You see that? Now, we have this part here that I think you remember. Yeah, it is here. PA here. To OA is equal to root of 7 to 1. And like I said before, this means that PA out of OA shall be equal to root of 7 out of what? 1. And then therefore PA shall be equal to the root of 7 times the OA. Okay? So what is PA? Of course, PA, this one here is the same as saying that you are getting PA here, it's a length. So we are supposed to get this vector PA, then this one will be equal to root of 7, then the magnitude of also the vector of OA. Is that clear? Then how do we get PA? PA here will be OA, you get the last minus the first. So OA minus OP. We proceed. Our OA, and I put the modulus here. Our OA, I think we got it here. OA is 2, negative 1, 0. So 2, negative 1, 0. Then OP is this one here. Lambda 0, negative lambda. Then this one will be equal to the root of 7, then times the modulus of, but do you remember that the modulus of this OA was root of 5? We calculated before. Then we can proceed and say that this one can be the modulus of 2 minus lambda, then negative 1 in the middle here, and then lambda here. Then this one will be equal to root of 7 times root of 5. Then how do we get the magnitude here? We shall have 2 minus lambda. We can have 2 minus lambda squared, then plus negative 1 squared, then plus lambda squared under the square root, not so? Then here I can just say the square root of 7 times what? 5. Now, when you look at this, don't you think the square root signs are going to cancel, or you square both sides, not so? Now let me reserve the space here. I think I'm not going to open the next page. Let me just use this one here. Now, here we are going to open up the brackets. So we shall have a 4, then square this. I mean, this one will be 2 times this times that. That is minus 4 lambda. Then square this one here. You get lambda squared. Then plus a 1, then plus lambda squared. This one will be equal to 35. So this is, I think there is a 1 here. Yes. Then lambda plus lambda, that is 2 lambda squared minus 4 lambda. Then bring this on this side. So you have 4 plus 1, that is 5, minus 35. That will be minus 30, which is equal to 0. Divide all through by 2. We shall get lambda squared minus 2 lambda, then minus 15. Okay? Minus 15. And this one will be equal to what? To 0. This one can be factorized. Two numbers, when we multiply them, they give us negative 15. But when we add them, they give us negative 2. Isn't that negative 5 and positive 3? Yes. So I will have this solved by factorization. So lambda plus 3 and then lambda minus 5 is equal to 0. So meaning lambda can be equal to negative 3 or lambda can be equal to 5. Now for these two values of lambda, we can get the two position vectors of P. So that's why I said it can be here or it can be here. Okay? Not necessarily here or maybe this other side, but wherever on this line here. Okay? Like that. So we can now proceed and we say, for each of these two values, what do we get? Now for lambda, which is equal to -3, what is OP? So our OP, put -3 here. That is -3, 0, then 3. Not so? Then for lambda, which is equal to 5, what is OP? OP can be 5, then 0, and then -1, 5. So these are the two answers that we are getting here. And that is that. Or you can even write them in terms of I. You say ij and k. So OP shall be equal to -3i. Now this is 0, so we don't have j. Then we can write 3k. Then OP can also be equal to 5i. Then plus, is it a plus or a minus? -5k. Like that. So that is that.